right, this quadratic equation is already in standard form, so we don't have to worry about that. The next thing we know it opens up because the leading coefficient is positive. So it opens up. So it's going to be something like that. All right, let's find the vertex. The vertex, let me write my equation. Well, that's okay. My equation is y equal x squared plus 5x plus 6. Okay, so the vertex is x equal negative b over 2a. And negative b, that's negative 5 over 2 times 1, which is negative 5 halves. Now take that negative 5 halves and plug it in your equation to find your y value. And that will be y equal negative 5 halves squared plus 5 times 5 halves plus 6. And that gives you a y value of negative 1/4. So my vertex is negative 2.5, that's negative 5 halves, comma, negative 1/4, which is negative 0.25. You can leave them in fractions or put them in decimals. Whatever. Now, the next thing you want to do is find your y-intercept. And your y-intercept is where you let x be 0, and that's going to give you 6. And x-intercepts, if they exist, you're going to let y be 0. So that gives me 0 equals x squared plus 5x plus 6. And that factors into x plus 3, x plus 2. And that gives me x-intercepts of negative 3 and negative 2. Now, we have a parabola that opens up. So do I have a maximum or a minimum? I've got a minimum. Okay, let's graph this thing. I've got a vertex of negative 2.5, negative 1/4. So negative 2.5, negative 1/4, about right there. And I've got a y-intercept of 6. 1, 2, 3, 4, 5, 6. Now, if you were to draw a line draw a line through the vertex, it cuts the parabola in half. So that's a line of symmetry. So if I know that this point, let me change colors. I know from here to here, which is to the vertex, with a vertical line that cuts it. I'll go ahead and draw one. That line cuts it in half. And that's 2.5. From this point over to that line is 2.5 units. So that means 2.5 units on the other side. I've got another ordered pair. And I get that by symmetry. So my parabola, and what else do I have? X-intercepts of negative 3 and negative 2. Negative 3 and negative 2. So I've got right there, negative 3, 1, 2, 3, and negative 2. So that just helps me be a little bit more accurate about my parabola. And if I sketch that thing, there's a parabola. And there's my minimum. And it's increasing. Remember, you're going to write that in terms of x. You can draw tangent lines if you want to. And the slope of the tangent line tells you if it's increasing or decreasing. Tangent line touches your curve at one spot. So it's increasing from here on. It's not increasing or decreasing at the vertex. And our vertex was what? Negative 2.5, negative 1/4. So it's increasing from negative 2.5 to infinity. I'm using interval notation. Okay? And that says x increases y is also increasing. And it's decreasing over here. So it's decreasing from negative infinity down to negative 2.5. All right, now let's do another example. See if I have more room on this next page. Just repeat what I've just done. This thing's opening down. It's in standard form. It's opening down. It's going to look like that. And that's going to be a maximum. My vertex is x equal negative b over 2a. And that's going to be negative 8 over 2 times a negative 1. And that's going to be 4. And then to find your y value, you're going to plug in 4 back in for x. That's negative 4 squared plus 8 times 4 minus 12. And that gives me a y value of 4. So my vertex is the ordered pair 4, 4. So 1, 2, 3, 4, 1, 2, 3, 4. There's a vertex, and it opens down. Now my y-intercept, let me erase, y-intercept is where x is 0. It's going to be negative 12. Okay? That's going to be y equal negative 12. And then my x-intercept is where y equals 0. So that's 0 equals negative x squared plus 8x minus 12. Multiply both sides by negative 1. That's 0 equals x squared minus 8x plus 12. And that thing's going to factor into x minus 6, x minus 2. That gives me x-intercepts of x equals 6 and x equal 2. So x equals 6. Well, there's x equal 2 right there. 1, 2, 3, 4, 5, 6 right there. And then way down at negative 12 is where I have a y-intercept. But my parabola looks like that. And we have a maximum. I think we've already said that. And let's draw some tangent lines on both sides of the vertex. This thing is increasing. It's increasing from here up to here. As x increase, let me get another color. As x increases, y is increasing. So it's increasing from negative infinity up to 4. Vertex is 4, 4. It's in terms of that 4 right there, x. And it's decreasing on the other side. And that would be 4. Do not include it. And where's it going? This is x is going to positive infinity. And that's your graph.